Graphing cosecant and secant functions. Cosecant function is the reciprocal of sine. So it will have some of the same properties that the sine of x has. When we graph it, you'll actually see me graph sine of x first, and then we'll turn it into the cosecant graph. The amplitude is still going to be the absolute value of a. The period is still 2 pi divided by b, but remember, b must be factored out of our general function here. So sometimes you will have to factor this out. The phase shift, in this case, would be b divided by c, but it'll be the left or right. Remember, inside is opposite. And then the initial interval, we're going to stick with the 0 to pi range, and you're going to see what will happen with that. So for cosecant of x, again, CSC, it's the reciprocal of sine. So let's think about what do we know about sine of x. Typically, the period for sine of x is 2 pi. Switch to a pencil here. 2 pi with no phase shift, so from 0 to 2 pi. And the amplitude is 1. Sine starts on a 0, ends on a 0, and the middle value at pi is 0. A quarter of the way through, we get a max. 3/4 of the way through, we get a min. And this would graph our sine function. We'll repeat this pattern for the rest of the graph. Forward and backwards. Now, you can see the sine curve. In order to turn it to cosecant, let's think about what does it mean to be reciprocal. Well, it's essentially 1 divided by sine of x. So let's start with the zeros, because I know I've graphed 3 of them here. What's this reciprocal of 0? So let's think, what's 1 divided by 0? Anybody? It's undefined. So everywhere there was a 0, anywhere where we're looking at either our shifted x-axis or the actual x-axis, wherever that 0 occurs at, we're going to get an undefined value. So I'm going to go through the graph and mark every one. This is creating an asymptote all the way across. So right here, at these intervals where these zeros occur, it doesn't really exist there. It's not part of the domain for cosecant because it's undefined. Does everyone have that? Now, let's look at the other points, the maxes and the mins. Right now we have 1. What's the reciprocal of 1? Well, 1 divided by 1 is still 1. So these points, the 1s, are still going to exist. And so do the negative ones for that matter. And these are actual points on the cosecant graph. If you think about the traits of an asymptote is where the line gets closer and closer to it, but it never touches. So here we have 1/2. The reciprocal of 1/2 is 2. Here's a 1/2, so its reciprocal is 2. So if you can see this line gets closer and closer to that asymptote, but never touches. Closer and closer, but never touches. And that pattern holds true on all of these. And what you see graphed in orange is the cosecant function. Again, I used the actual sine graph, so I would graph the sine graph, or in a moment the cosine graph, according to the equation and what we've done for the past 2 weeks. Then we're going to turn the zeros into asymptotes and the maxes and mins into the curves. All right, let's do it one more time with secant. Secant is the reciprocal of cosine. So that is 1 divided by the cosine of x. Right, the amplitude is still A. The period technically is 2 pi divided by B, or in this case, normally 2 pi. The phase shift is typically 0 unless you have a C value. And the initial interval is going to go between 0 and 2 pi. So let's think about cosine. Cosine has an initial period of 2 pi, so from 0 to 2 pi, with an amplitude of 1. Cosine starts on a max of 1, ends at a max, the middle is a minimum, and a quarter of the way through we get our zeros. It's got to cross through that x-axis. Again, we're going to repeat this pattern throughout the whole graph. And just like with the sine graph, all of the zeros you see here, when we start looking at secant, are going to turn into asymptotes. So as I transfer from the cosine graph that I have here in pencil into the secant graph, everywhere I see a 0, here, 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 all of these zeros are going to turn into asymptotes because the reciprocal of 0 is undefined. Remember, the difference between sine and cosine is a phase shift. So the difference between secant and cosecant is also going to be a phase shift. The graphs are going to look really similar. It's depending on where those maxes, mins, and zeros are. So you can see the asymptotes. Every maximum, you're going to get that asymptote in that curve. Now, what you see here, graphed in orange, is one period or one cycle of cosecant. The same thing here. You see those two. That's the period for, cosecant on the top, secant on the bottom. It'll still continue that pattern. I'll change colors just so you can see that it does continue forever, just like sine and cosine do. But they're not typically in that initial interval. Probably should have done that above, but I'll come back and highlight. So there's our secant and cosecant graphs. Again, initial interval here, just so you can see it. Here and here. All right. Good luck with the transformations.